Which pancake is the oldest one? And which pancake is the newest one? Take a second to think about it, and you can share your answer with the group. Okay, your oldest pancake is going to be the pancake at the very bottom, and your newest pancake is the one at the top. So if you are cooking pancakes and you're just moving them over to a plate, then the first one you cook, you put it on the bottom, and then the next one on top, and you continue to stack them until the very newest pancake is on the very, very top. So why am I showing you this picture? Well, I'm not just trying to make you hungry. It actually has a purpose, because the same concept of the oldest on the bottom and the newest on top is going to be something that we see also with rocks. But let's take just a second to admire just how wonderful these pancakes look. Let me tell you, when I cook pancakes, they look a lot more lumpy and not nearly as pretty. But it does make me crave pancakes. Okay, but let's keep going. So, looking at, hold on one second while the screen catches up to me. There we go. So, looking at this picture, what do you notice? Well, some of you may notice that this is a picture of like the Grand Canyon, and see how there's all these different layers. Just like the pancakes had layers, you can see the layers within the rock. So we are going to look at how you can tell the relative age of rocks, and layering is one way that you can do that. So some other ways we can do that are going to be seen with this little activity we're going to do called Who Done It. So I've got a bunch of little half sheets of paper that have trails on it, different people who have walked, and you are going to decide who took the cookies last. So go ahead and have those passed out, and pause this video while you decide who stole the cookies. Okay, the person who stole the cookies is the blind nephew and his dog. And that just makes me wonder, is he even blind? Who knows? Okay, so I'm using the same things the same logic that you used to figure out which pancake was the oldest and newest, and using the same logic you used to find out who stole the cookies. That's the same exact thing that we are now going to apply to rocks. The way that you know it was the nephew and the seeing eye dog that stole the cookies was because he was in the kitchen last, and you could tell that because their footprints and paw prints, they overlapped everybody else's prints, but nobody's overlapped theirs. So let's go ahead and continue with our notes. So here are your first two laws that are going to help you tell the age of rocks. The first one is uniformitarianism. Everybody say uniformitarianism. Uniformitarianism is a long word that's just kind of fun to say, but the first part of the word is another word that is very familiar to you, or should be. Uniform. So if you are wearing a uniform, then you are dressing in a way that is supposed to make you look the same as everyone else. And that's what this law is saying, that rocks form in a uniform manner, aka the way rock layers form is the same now as it was in the past. So uniform is simply talking about being the same, and your rock layers formed the same way now as they did 100 years ago and 1,000,000 years ago. It's not like all of a sudden rocks just spontaneously come out of the sky when before they had some long process. No, it's the exact same way. And this again is talking about layers. So we are really specifically looking at, it comes into play with this next law, superposition. But the layers form down in the same way. So superposition is saying the rocks on the bottom are older than the rocks that are on the top. And that's because of the same thing that we saw with the pancakes. If there's a layer of rock that doesn't just form floating in midair, and then all of a sudden more rocks are formed underneath it until it connects to the earth. No, your rocks start on the top of the crust, and then as more sediment and stuff gets put on top, they eventually become new rocks that layer above it. Just like I stack pancakes from the bottom and go up, rocks are stacked from the bottom and up. So they form now the same way as they did in the past, and the way that they're forming is the older on the bottom and the newer on top. So I'll pause just to give you a second to finish writing this, and then I will switch to the next slide. Okay, I'm going to clear the screen and move on. If y'all still aren't done writing it, you can pause the video, but I'm going to keep going. Our next law is the law of horizontality. So the law of horizontality is saying exactly what it sounds like. Rocks are formed in horizontal layers. Rocks don't stack up in one single tall column and then go next to each other. They form one long row at the bottom and then continue to stack on top of that. Just like you did with your starburst. You made a horizontal line of one color of the starburst, and then you put another on top and then another on top again. So that's what we see. They are horizontal and then they stack up from there. If there's ever a time that you're looking at rocks, say you're looking at the edge of a cliff and you can see the rock layers that are exposed, then if they aren't straight, say they're curved or they're bent, then that's not because they formed that way, it's because the earth has actually moved. For instance, when the earth is creating mountains, we do see a lot of movement with that. So the law of horizontality is saying that they're horizontal. If they're not horizontal, it's because of the earth's movement. And that is what is changing that up. So again, I will pause just for a second so y'all can finish writing, and then I'll go on. Okay, hopefully you're done writing. If not, the awkward pause was just getting awkward for me. So if y'all need to pause the video to finish getting this definition down, you're welcome to, but I'm going to keep moving to the next one. Cross-cutting relationship. This is saying that if a layer cuts through something, then it's going to be younger than what it's cutting through. And this makes sense. Think about if you have that same stack of pancakes. Well, if you cut through all the pancakes, then that means the cut mark that you made was newer than the pancakes were. You can't cut through something that isn't there. So anytime something is moving through another thing, you know that thing had to be there before that line could come through it. So looking at this picture, because this rock gives you a good example of that. You have the rocks, and notice they're horizontal layers. And then you have this thing that we actually call an intrusion. So right here, this little S-shaped line, it's cutting through all those other layers. So we know that this S-shaped line is newer or younger than everything that it's cutting through, because it couldn't cut through something that wasn't there. So you had your horizontal layers form first, and then after that, you had this S shape come in. And so if we were looking at this rock in terms of layers, now this is a little piece of rock, but say we knew what was the top and what was the bottom, then we would say these layers at the very bottom are going to be the oldest, while the layers at the top are going to be newer, and this thing that cuts through them all is the newest. And let's pretend I wrote newest. But that's kind of how these different laws are working. These rocks are forming the same way now as they did in the past. That's the uniform thing. So we can see that these laws aren't changing. They all formed horizontally, and then what cut through it, cross-cutting, is going to be newer than everything that it has cut through. And again, I'll give y'all just a second to finish writing that. Okay, I just have two more things, and then I'm going to let y'all do a little activity. So two terms that you need to know, an intrusion and an extrusion. Notice this picture down below is showing you the same picture you saw from the previous slides that were talking about intrusive and extrusive rocks. This is basically the same thing, so you should already be very familiar with it. So an intrusion is molten rock that is going into existing rock. So I apologize because this program kicked me out, so I may be repeating myself a little bit. But an intrusion is molten rock that's cutting into existing rock. It does not reach the surface. It's inside the surface. The difference in what we looked at in the previous notes with intrusive igneous rock and extrusive igneous rock is that was an intrusion and extrusion that had become a rock. What we're looking at right now is something that is still molten. It's melted, so it's not yet a rock. Same exact concept. One, we're just talking about intrusive rock. Now we're just talking about the intrusion. So it's very similar. But anyway, intrusion inside the earth. So it's molten rock cutting into other rock, and it does not reach the surface. So on this side, that would be an intrusion. Once that intrusion cools and hardens, it would become an intrusive igneous rock. On this other side, you have extrusion. Extrusion, again, will exit the earth, and it will go onto the surface. So this does not reach the surface. This does reach the surface. And that's what you see on the picture over here. Your extrusion has exited the surface, and it's going to cool and harden. And once it does cool and harden, it will become an extrusive igneous rock. So those are your two terms. Hopefully that makes sense since we've already looked at intrusive and extrusive. Go ahead and finish writing that down. And then I have one other term you need to know before I give y'all a little bit of a break where you can practice the rules that we've looked at. So moving on. Index fossils. Some of you have probably heard of index fossils. Think about if you have the index of a book, you're using that index to look something up. It's a reference page for you. Well, that's what these fossils are. They are a reference that we can use to look up the relative age of the rock. So index fossils are going to be fossils of organisms that were only around for a very particular time. So not all organisms, once they die and become a fossil, would be considered an index fossil. Only particular ones are. So for instance, the one that everybody can probably think of is a dinosaur. We know dinosaurs lived on the earth for a very particular time. So if we find a fossil of a dinosaur, then we know that rock has to come from that same time frame that dinosaurs were alive. That's why it can give us the relative age of that rock layer. So we would know that everything in that rock layer is about the same age as the dinosaurs. And so that gives us a range of a couple million years where that rock could have existed. So that's all that your index fossils are. There's a couple of index fossil picture examples at the bottom. Some sort of fish thing, and I don't know what that other stuff is. You could always look them up later if you really have a strong interest in it. But again, that's just to help you determine the age of that particular layer of rock. So now that you have a good understanding of all the different laws, let's see if you can put them into practice. So I'm going to show you you'll just need a scrap sheet of paper for this, or you can just write it off to the side in your notes. But I want you to try to label these layers of rocks from the oldest to the youngest. So oldest from the youngest, see if you can do that, and pause the video while you do that, and when you resume the video, I will give you the answers. Okay, for this first one, I'm going to go ahead and listen from oldest to youngest. So you have C. I'm going to change the color. We have C, E, D, B, A. Now, the reason why I have it this way is remember, the oldest is on the bottom, newest is on the top, just like a pancake. So I know that C had to come first, second, third, fourth. And then you have this intrusion, which is A, that cut through all the layers. Therefore, it's the youngest of everything. Now, if I were giving you this on a test, this is the answer that the workbook had. But if I was giving you this on a test, I would also accept the answer C, E, D, A, and then B. Because what some students, when they look at this, think is the intrusion cut all the way through, became an extrusion, exited the surface, and then B formed on top of it. I personally would accept that answer because when I look at it, that looks like what happened to me as well. So those are your two answers. As long as you know the other part, then A and B, they are debatable. So let's do another one that's a little bit harder, but I believe in y'all. So here you have a picture. Now, I do want to point out, and I'm going to erase these lines, but see B right here and see A. If you want to include them, you can't, or not A, this is E, excuse me. This is E, this is B. Those two lines are fault lines. So that's like a crack that happened in the rock. So if you want to try to include the two faults for E and B, you're welcome to. I'm going to include them in the answer. If you want to ignore them, then you're welcome to as well. But so you have layer C, see how they were lined up, but they're not anymore. And layer A, that was lined up, that's the one that looks like bricks but aren't anymore. That's because that fault came in and shifted them down. And then same thing with A. So do your best to try to figure out the age of the layers. As extra bonus, try to add in B and E as your faults. And pause the video while you work on it. So here are your answers. First, remember, we're going from oldest to youngest. We had G that formed, then C, then we had A, then you have F, then B, H, D, I, and E. So we know that E is going to be younger than pretty much all these layers because it cuts through all of them. Fault B is only going to be younger than what it cut through. So B is cutting through G, C, A, and F, which is why B has to go above all of those. After you had that fault, then you had layer H come to form, then you had layer D come to form, then you had layer I come to form, and then a fault broke through them all. So the fault E is all the way at the very top. So the next slide is just going to, if y'all want to debate that a little bit, you can, but these are the answers. If you need to pause so that someone can explain to others why the answers are the way they are, you are welcome to. On the next slide, I'm simply going to have the same answers listed out. So I'm going to go ahead and clear the screen. So again, there's your answers: G, C, A, F, B, H, D, I, and E. Let's do another one. Personally, I think this next one's not quite as hard. So here you have some curvy things. So remember, the law is horizontality. If anything is not horizontal, it's because there has been movement in the earth. So we can see some movement and some shifting that has occurred here. Again, G is a fault that's breaking through it. So go ahead and pause while y'all figure out the oldest to the youngest. So your answers for this one is D, H, A, C, G, F, I, B, E. So the very first layer that we had formed was D, and then H. So D formed first, H formed after that. Then you had A form. Then you had C that cut through them. It's an intrusion, so it cut through those, so we know it's younger than them. Then you have, I meant to write the next number, which was a 4. Then you had G, which is the 5th thing, because it cut through all of that. Notice up here, it's also cutting through that intrusion. After that, the 6th thing to form was going to be F. Then you had I form. Then you had B form after that, and then E formed on all of those above it. So that is your answer. And so again, on the next slide, all I have are the answers listed out as far as being typed up, so it's a little bit less messy. Feel free to discuss this if you need to, if y'all have any questions. And then we will just move on with plate tectonics. Hope y'all enjoyed that practice. If you like puzzles, then maybe you did more so than some other people. But that is all for this set of notes.